Hey guys, welcome to my intro tutorial on types. Before we begin, if you haven't watched my tutorial from week 01 on installing Haskell, or the tutorial on intro to functions from earlier this week, I recommend you watch those first. Now without further ado, what are types? A type is the name of a collection of related values. So for example, we have a type called bool that contains two logical values, false and true. Similarly, there are other types like int. Int will contain numbers 1, 2, 3, 4. Actually, that's a collection of an infinite amount of different values. In Haskell, every value, variable, and function is going to have a type. So here's the integer type we were just talking about, which would be the same as 1. Now, to make things a little bit confusing, we're going to separate whole numbers and decimal numbers into integer and float. And in fact, there's going to be even more types than that to deal with numbers. So 2.0, you see, is a float type here. And there's even other types like string types that can hold words. So if you want to represent the word hello, you could assign that to a variable x, and both that variable and the value itself has the type string. Now Haskell is a strictly typed language, which means that every variable has a type, and that type is never ever going to change. So this creates the opportunity for type errors. Let's say you have an expression 5 plus 2. Now it gives back an error message, and this error message has a number of things going on. You're going to fully understand what exactly this error message is telling you by the end of this course. But for now, let's just focus on the fact that it's saying num bool doesn't exist. So the idea here is plus is an operator that works on num values, okay? It works on any sort of num value that could be an int or a float like I showed you before, but it doesn't work with bool values. So remember, bool is that type. It has true and false inside it. So when you try and use plus with true, it gives you a type error. So every expression E is going to have some type T, and we donate the type of stuff in Haskell using this double colon operator. So we'll say E double colon T means whatever that E thing is, it has type T. Okay, so every well-formed expression, which means every valid expression, right? Every expression that isn't just like an error right off the bat, has a sort of type. And you can open up GHCI and you can use the type command, this colon type, to see what that type is. So let's open up VS Code and let's play around a little bit, get a hang of what these types are. So like I mentioned before, we have like say x equals 5. Okay, and you'll notice the nice thing if you installed the extension, whenever you write a variable or a function, it'll tell you the type. The type will automatically appear above it. And if you click on it, it'll be there forever. Okay, it'll actually insert text there to leave there. So this is actually known as a type signature, as we have above here. And let's have another variable here. Let's make it a Boolean variable. Okay, and see, this is a bool. I'm going to click it there. Okay, so let's try and make a variable z now that's going to be the addition of these two variables, x plus y. And here's the cool thing about VS Code. If you installed the Haskell extension, you don't even have to load this into GHCI to see that there's currently an error in your code. So you probably have hopefully already noticed this. It underlines errors in its kind of reddish orange here. Okay, so it's saying that there's an error here, and if you want to see exactly what that error is, you should try loading it into GHCI. So we can load GHCI, so save and load this into GHCI. Okay, and you'll see it tells you, let's make this a little bigger. We have an error here. Couldn't match expected type integer with actual type bool. Okay, so we had an error caused from the plus, and it's saying, this y here, I wanted it to be an integer. I expected it to be an integer. Why? Because x is an integer here. Okay, I expected it to be the same thing as x. If I'm going to add two things together, and the first thing is an integer, the second thing should also be an integer. But the actual type is bool. Y is actually bool. So you'll see whenever when working with type errors, it'll always kind of write it out this way. I expected it to be this. Okay, so what it's saying is I need this thing to be this, but its actual type is this. And then it tells you what it's talking about exactly. So it says in the second argument of plus, namely y. So it's saying I need y, I expected y to be an integer, but it's actually a bool. Okay, so now we need to go in and be like, how can I fix this? How can I make this better? Well, maybe y shouldn't be a bool. Maybe it should be an integer. So maybe I meant for y to be equal to 0. Okay, to an integer type. And you'll see that now the error disappears. Now nothing is being underlined. And if I load this into DHCI, it loads fine. Okay, it says one module loaded lib. Okay, it's fine and dandy now. And now we can ask it, what is the type of Z? Okay, colon type. He tells me Z is an integer. Well, I already kind of knew that because of my nice fancy feature here. But I could also ask it, like, what is the type of, say, Z plus 6? That's also an integer, okay? And if you're ever wondering what the type of an expression is, you could ask GACI like this, or you could just take advantage of the fact that we have a super fancy editor, and you can just write it inside here. So you can just write Z. You'll have to assign it to something, so you'll have to be like E equals Z plus 6, and it'll appear right above. Pretty cool, eh? Now, as some of you might have also noticed, you can make this even easier on yourself. So let's say you have a type error here. Let's just get rid of this for a moment. And it's underlined and there's an error. And you don't even really need to even load it into DHCI. Just put your mouse over top of it and this thing should pop up, okay? And you'll see that it lists the error right in there, okay? So it says, couldn't match expected type integer with actual type bool. If you watched my last tutorial, you remember I brought up the list type. The list type is such an important type that I kind of need to bring it up right away. And this is the type that allows you to group together other elements, okay, into one type. So it allows you to say we have a type of the list of strings. So this is a bunch of strings grouped together. Now notice the list type, everything in the list type has to be the same type. All of the elements of a list have to be the same type. So we can't have a list, for example, of 1, and this is a char here. It's in the single, so it's just a single A. It's a single character. We call that a char type. Or string. So this is string is a bunch of char types put together. So we can't have this list. It's a bunch of different types. Every element is a different type. It'll give an error. If we need to group together a bunch of values that have different types, we use a different data structure called a tuple. So a tuple is specified using round brackets, and a list is specified using square brackets. So a tuple can contain a bunch of different types. So that example that we just did, that's fine inside of a tuple. So the way you specify the type of a list, because every element has the same type inside of it, you just have to specify list of char. So let's say you have a list of 4 things and they're all char, which they have to be. You'll just specify square brackets char. And this is true if there's 4 things. This is true if there's 5 things. This is true if there's 100 things. And on the other hand, a tuple, you need to specify everything inside of that tuple. So if you have a tuple of 2 things and both of them are bool, you have to specify bool, bool. If you have a tuple of 3 things, you need to specify, so this would be a char type, char, this would be a bool type, bool, and look, this is a list of char. Okay, so you can have a list inside of a tuple. So you can have a list of char here. So you might be wondering now, when would you use a list? And when would you use a tuple? So it's clear that, well, if I need to group together things that have different types inside of them, well, then I need to use a tuple, right? But when would I want to use a list then instead of a tuple? Let's consider a function, okay, that we want to work over a list, okay? F of x's, and we want to take out the first element of x's. Okay, so this is going to have a list type here. Now you'll notice the way I would define this with a tuple, I would have to specify that, well, if f was a tuple, if it took a tuple, I'd have to do something like bool goes to bool. So this would be the type of it takes a bool and it returns the first element of that bool, where this is, if you look at this thing's type, this thing takes a list, let's say there's bool inside of it, and returns a bool. Now, what's the difference between these two things? Well, in this example, you'll notice I don't have to specify how many things are in this list. This list can be, true, it can be just one thing, or it could be true, false, it could be two things, or three things. It can just keep going. I don't have to specify how many things are inside of this list. Whereas with the tuple, I would have to specify exactly how many things are inside of that tuple and what type at each position inside of the tuple each thing is. So I just showed you a few examples of both the char and the string types. Now I mentioned that the char type, which is wrapped in single quotations, just holds a single quick character. So you can't, for example, write something like x equals single quote AB. You'll see this is an error right off the bat. This is not a valid character. But x equals just A, this is fine. Okay? Or x equals, or it would be if there wasn't already an x, B equals just A. You'll notice when I did the x here, if I look at the error here, it says multiple declarations of x. So you can notice right off the bat, oh, there's already an x defined. We can't define x twice. Let's use B equals A. This is a perfectly valid type, but B equals A. B, not so good. This is not a valid char. Syntax error on AB. Okay, not a valid char character. Now, on the other hand, if we wrap this in double quotations, AB, this is a valid char character, or string character now. And you'll notice the type of it is list of char. But what's going on here? I said that this was a string, not a list of char. Well, it is a string. You'll see this is also fine. The reality is a string is just a special name for a list of characters. So it's just multiple characters put together. And this is just as valid, so calling it a string with double quotations and putting these characters inside here is just as valid as putting, say, the square brackets, then single quotes A, single quotes B. Same thing. These two things are equal. So if I were to find A equals AB and say that A is a list of char and B is single quotes A, single quotes B, and it's a string, or it's a list of char, it doesn't matter, same thing. These are all the same thing, okay? All equal to one another. In fact, you can even check this. I could load up GHCI here, and I could ask it, is A equal to B? True, they're the same thing. A few moments ago, for the purpose of showing the difference between a list and a tuple type, I showed you the function type. So the type of a function is specified using this arrow-like operator that basically says the inputs of the type and the output of the type. So not, for instance, is a function that takes a single input of type bool and it returns a output also of type bool. So another example of this, we could define a simple function f x y equals x plus y. So this function, it's trying to give us a more complicated type, but we can give it a simple type of f double colon int, let's say integer goes to integer goes to finally integer. Okay, so what we're specifying is that x is an integer, y is an integer, and then the result of x plus y, which we can check, what's going to be the result of two integers added together, is going to be another integer here. So do know some types are more complicated than others. So when I tried to write f, it gave me a more complicated type. Let's say the type of head. So head, if you remember, is a function. It takes a list and it returns the first element of that list, and it gives the type list of a. And you'll notice usually types begin with uppercase letters, but we have this a here, this lowercase a. What's going on here? So a is not actually a specific type. What we're going to talk about in the next tutorial is that head is able to specify it's a list of any type a. So we'll talk about this more in next tutorial. This is called polymorphism. Now, whenever we write functions, we should always put the type signature of the function beforehand. So you'll notice that VS Code, being super high-tech editor, always just kind of puts it there for you by default. Now, it actually doesn't actually put it inside there unless you click on it. It just kind of appears there, and it isn't really there as in there in text. When somebody else opens the file, they'll see it as well, even if they're not using VS Code. So I recommend whenever you're writing something in VS Code, let's say hello goodbye equals hello plus goodbye, right? I recommend actually putting the type signature there. So not just leaving VS Code telling you what the type signature is, but actually clicking on it and putting the type signature there. So that means whenever somebody else opens this code now, even if they're not using VS Code, they'll be able to see the type signature. And it's a very good idea to always have your type signature on top of functions and variables, just so that it makes it way easier for the programmer to figure out what's going on. A lot of the time, it's very easy to tell what a function does just by looking at its type and the name of the function. So if you have some function like fxt, this is a function fist that takes an ab and returns an a. Okay, what do you think this function does? Well, it takes a tuple of two things, and what do you think it's going to do? Well, it takes a tuple, and the first thing has type a, and the second thing has type b, right? And it's called fist, kind of like for first, right? So you could guess that it's probably just going to take a tuple of two things, and it's going to return the first thing. So for this reason, it's very good idea to have a type signature above all of your functions. So I hope you enjoyed my intro lecture to types. There's still a lot more to learn about types. They're a very powerful mechanism inside programming language, and I hope you're as interested to learn more about them as I am. Thanks. See you later, guys.